classified into two broad categories. One is called as electrophiles. Electrophile. Another is called as the nucleophile. Phile means loving. So this is also called as electron loving or electron attracting, electron loving. This loves electron, and this is nucleus loving. We can call it as nucleus loving. Since this loves electron, that means it has to be positively charged. Therefore it will be represented as E plus, positively charged, since it gets attracted towards electron. And since this is nucleus loving, nucleus is generally positively charged because we for understanding purpose we say it is positively charged. It has protons and neutrons. Therefore nucleophile will have a negative charge. So any species with a positive charge we call that as an electrophile, and any species with a negative charge we call that as a nucleophile. Okay, so we will see this in more detail about what are electrophiles, what are the examples of electrophiles. Now, as we have seen, the plus sign I told you, plus sign means empty orbital, I have already told you, which means they are electron deficient, as is evident from this. Since it carries a plus sign, this will be electron deficient. Okay, now if you see the examples of electrophiles, that include H plus, proton which dissociates from an acid, or if you take an aqueous solution of an acid, you get a hydronium ion. Any species which carries a positive charge, any species can carry a positive charge. Chlorinium ion, brominium ion, iodinium ion, anything, all positive charge will be suffixed with EM like this. EM will be a suffix as carbonium, or carbocation we say carbonium. Similarly NO2 plus, NO plus. So all these species are called as electrophiles because they lack electrons. So we have N2R or N2 plus, and then you have the carbocation. R means alkyl group. R represents alkyl group, methyl, ethyl, propyl, as we have seen in the previous reaction here. So here we saw the ethyl carbocation, so that is represented by R here in the case of electrophiles. So what are the electrophiles? Are electron deficient species which during the course of a reaction will try to accept electrons and then proceed in the reaction. Electrophile. So since it accepts electrons, we can call them as Lewis acids. So what are Lewis acids? Group 13 la nama paathom. Any species which can accept a pair of electron is called as a Lewis acid. So what are Lewis acids? Accept a lone pair of electrons is called as Lewis acid. When it donates a lone pair of electron, we call that as a Lewis base. Pinal nama the nucleophile paaka porom. Now nucleophile, as I said, nucleophile is a nucleus loving, which means it will carry a negative charge. It will carry a negative charge. This nucleophile will be in turn further divided into negative nucleophiles and neutral nucleophiles, which means although the species is neutral, it will still try to get attracted towards the positive charge. So those are called as the nucleophiles. So negatively charged species means you can have a host of examples. You should be able to identify the nucleophile given in any reaction. I'll be giving you the worksheet so you can try to solve that. Hydride ion, chloride ion, bromide ion, iodide ion, all these negatively charged. So carbon ion, there we saw carbocation R plus, here we see carbon ion. Maybe you can write it down. Carbon ion. So RC triple bond C minus alkynyl ion or acetylide ion. Since there are two carbons, we call this as acetylide ion. So any species with a negative charge will be called as a nucleophile. There are many species. You can keep on listing that. OH minus, SR minus, thio group, and C6H5O minus. Phenol, if you remove a hydrogen from phenol, it's called a phenoxide ion. And then you have the ammonia and the hydrogen remove panna. Or hydrogen remove panna, you get NH2 minus, and nitrate remove panna, you get NO2 minus, HCN, CN minus, and then carboxylate ion. So any species which carries a negative charge are called as negative nucleophiles, which will carry a negative charge on their head, so they'll be called as a negative nucleophiles. And there are some neutral nucleophiles which will have a lone pair like this. Say for example, these things include, the examples for neutral will be include, you have oxygen which carries 2 lone pairs. So if you look at water can act as a nucleophile. So any species which has got a lone pair of electron can act as a nucleophile. That means it can donate, it gets attracted towards the nucleus, or you can say that it carries a lone pair which is equivalent to that of a negative charge. So any compound which carries nitrogen and oxygen, which of them will be carrying, wherever you have oxygen, you have a lone pair, 2 lone pairs. So alcohols, ammonia, amines, water. So all these things, then thiols, you will be seeing all these things in your next year, thiols, ethers, any species which contains O. Any species which contains O will, number path in the reagent, CH3MgX, CH3MgX. So all these compounds are neutral nucleophile which can it doesn't carry a negative charge as it is, but they have a lone pair of electrons. So since these species can donate a lone pair of electron, all these will donate a lone pair of electrons. So therefore they will be classified as Lewis bases. So nucleophiles act as Lewis bases and electrophiles act as Lewis acids. So this is what you have to remember. So there are some exceptions, not exceptions. You will be having some compounds where you will have, say for example, now if I ask you one question, now answer this question. R4N plus. This is something similar to NH4 plus. NH4 plus ammonium ion. NH4 plus ammonium ion. Okay, so now tell me whether this is a electrophile or a nucleophile.